Hey there guys, Mr. Carlson here. Let's take a look at this reaction mechanism example problem. So we have the balanced equation for the reaction of the gases nitrogen dioxide and fluorine. They give us the balanced overall equation, 2NO2 plus F2 to give us 2NO2F. And they also tell us that the experimentally determined rate law for this overall equation is rate is equal to K times NO2 times F2. So we have the overall equation, we have the experimentally determined rate law. They give us a suggested mechanism for this. So they give us two steps, one slow, one fast, and they want us to answer, is this two-step process here, is that an acceptable mechanism for the overall reaction? So remember, there's two things that this mechanism needs to satisfy to be an acceptable mechanism. The first thing is that if these two things add together, they need to give the overall balanced reaction. So let's do that first. Let's add these two reactions together. Now, what we're essentially doing when we add these together is first we're going to take a look, do we have whatever is on the left-hand side that is the same on the right-hand side, and we're going to cancel them out. So I see that I have F on this side, and I have F over here. And so F is going to cancel out since it's the same on the left as it is on the right. And that is actually the only thing that I see. Now notice I do have NO2F here and I have NO2F here, but those are both on the right-hand side. So they would need to be on opposite sides to be canceled out. Same thing with this NO2. They are both on the left-hand side of each reaction, and so I would not cancel them out. It would only be if like one of these was on the right-hand side. So now I can add everything together. I've got NO2 and NO2, so that means I'm going to go 2 NO2 plus 1 F2 to produce. I've got 2 NO2F. And I can see already, of course, that that is the overall equation that I have up here, 2NO2 plus F2 to give 2NO2F. So this mechanism does satisfy the first requirement in that both of these reactions add up to give the overall equation. The second thing is that the slow step, the rate law for the slow step needs to match the experimentally determined rate law. So remember, for the elementary steps, I can write the rate law based on how many reactants, that are colliding. So the rate law for the slow step here would be K times the concentration of NO2. And I only have one of them, so b raised to the first power times the concentration of F2. And again, just one of those. So raised to the first power again, and I can see that the rate law for the slow step matches the experimental rate law, and so this is an acceptable mechanism. So we can answer yes, because it adds together to give the balanced reaction, and the rate law for the slow step matches the experimental rate law. Another question that you might be asked along with this is, what is the intermediate? What is the intermediate in this reaction? To identify an intermediate, it is something that is produced or made in one step, and then it needs to be consumed in another step. So produced in one step, but then is consumed in another step. Basically, what we're saying by that is that it cannot be part of the overall balanced reaction. An intermediate, by definition, is something that shows up in the middle of the reaction and then goes away by the end, so that it doesn't show up in the overall equation. It's just something that is there, part of the middle of the reaction, and then goes away. So it needs to be produced in one step, consumed in another, and so that would have to be this F that got canceled out right here. So that fluorine atom by itself, that is the intermediate. Because if I look, it is produced in step 1, so it was made from this reaction here of NO2 and F2. there was F made, but in the second step, it's used up as a reactant, and I don't have it as a product here, which is why it got canceled out, because it's the same on either side, and so it's not part of the overall balanced equation. So it is made in one step, used up in the other. That's how you would identify the intermediate.